Solving one-step equations. We're going to concentrate on addition and subtraction first. So now that we know how to transfer words to equations with numbers and variables, we're going to solve them. When we are solving equations, we want to do the inverse operation. So in example number 1 here, you can see that it says x plus 4 equals 7. We want to get x alone. We want to get the variable by itself on one side of the equal sign. Because we are adding 4 to x, the inverse operation of that is to subtract 4 from both sides. Remember, whatever you do on one side of the equation, you have to do on the other. When we do that, our 4's cancel, and we are left with x equals 7 minus 4, which is 3. If we are initially subtracting from our variable, the inverse operation of that is to add. So y minus 3 equals 12. We will add 3 on both sides. Our 3's cancel, and we have y equals 15. So the whole goal with solving equations is to get the variable by itself, to isolate the variable. Some more examples down here. As always, show your work. The first one, notice the variable is already by itself. X equals 4 minus 7. You're just doing the math. X equals negative 3. Just watch your signs. Number 2, we are adding 5 to x. So to undo that operation, we're doing the inverse, which is subtracting. And we get x equals 5. Number 3, we will add 2 on both sides, and we get t equals 8. Slightly different number 4, the difference being that the variable is on the right side. This does not change anything. We still want to do the inverse operation. So to get r alone, we will add 4 on both sides, and we get 15 equaling r, or r equaling 15. Number 5 is a common mistake that algebra students make. Negative 9 equals 2 plus y. Again, we want to get y by itself. We want to isolate y. Notice what sign the 2 has right now. This 2 is a positive, right? There's a plus in front of that 2. So to undo that operation, we will subtract 2 from both sides. And when we do that, we get negative 11 equals y. So just please notice that that 2 is initially positive. We're adding that 2. Don't look at this plus necessarily, because that goes with the y. But we're looking at the sign directly in front of the number. Okay, number 6. We're going to add 5 on both sides. N equals negative 4. Seven, opposite of number 5, kind of. The 3 is negative. We're subtracting that. So to undo that operation, we want to add 3 to both sides. So again, don't just look at that sign, but look at the sign directly in front of the number. 8, same idea here, except we have a fraction. Fractions are just numbers. So we have 2/5 equals a minus 1/5. So to undo that operation, we want to add 1/5 to both sides. So a equals 3/5. A common mistake people make here is they see a fraction and they're thinking division, which you're not wrong. That is division. That does say 1 divided by 5. but in relation to the variable, we are just subtracting 1/5. So sometimes people think multiply here, but that's not correct. Look in relation to the variable. We're subtracting it initially, so we want to then add it, the inverse. Careful here that we have two negatives back to back. So if it's me, what I'm doing is I'm rewriting this. And I'm saying, what does r minus a minus 7 mean? That just means r plus 7. That's saying the same thing. I'm cleaning that up. Now I know to undo, I have to subtract 7 on both sides, and I get r equals 9. So always clean up the signs if you can. What I want you to try, sorry, not yet. We have to do multiplying and dividing. So the next page. Multiplication and division. Same idea in regards to our goal. We want to get the variable alone. So example 1 says 6 times x equals 18. The inverse operation of multiplication is division. So since we are multiplying the variable, to solve that, we want to divide both sides by 6. And we get x equals 3. Example 2, we have a fraction which is just division. So it says y divided by negative 3 equals 9. The inverse operation is multiply. So we want to multiply by the denominator both sides. And we get y equals negative 27. Notice the negative 3's cancel. And number 3, we have 2/5 times x equals 4. Two different ways you can think about this when we have a fraction. You can either just do the inverse operation, so we're just dividing by 2/5 on both sides. And you can just type it into your calculator, and you get x equals 10. Now what you'll see on the right side here, it says multiply both sides by the reciprocal. So that means the same thing. Multiplying by the reciprocal is the same thing as just dividing by the regular fraction. You will get the same answer either way. Okay, at the bottom, same idea here. We have 7x equals 14. We're dividing both sides by 7, and we get x equals 2. Inverse operations. Number 2, likewise, we are dividing. Number 3, y divided by 8 equals 4. We want to multiply both sides by 8, and we get y equals negative 32. Number 4, we are multiplying 1/4 times y. So we want to divide by 1/4. Or if we multiply by the reciprocal, we're just multiplying by 4. Same answer. 5, divide by negative 9. Careful with your signs. 6, x divided by negative 3, so we want to times negative 3 on both sides. 7, we are dividing. 8, we are dividing both sides by negative 3/4. Again, or you could multiply by the reciprocal, so you would do 12 times negative 4/3. Same answer. And number 9, we're dividing. Watch your sign. x equals 1. So that is solving with one-step equations. Now we're going to skip over in the notes, flip a couple pages to solving two-step equations. So solving two-step equations is still undoing operations, inverse operations. So what we just did was something like this: x minus 3 equals negative 9. We did the opposite operation, right? So we would add 3 on both sides, and we'd say x equals negative 6. Or for multiplication and division, we would do the inverse operation, and x equals negative 6. If you have more than one operation in the equation, it's two steps. We have to undo the operations in the correct order, though. So what we're doing is kind of reverse order of operations here. So normally if we have an expression, we always do parentheses first, and then exponents, and then multiplication and division, and addition and subtraction, right? So we have PEMDAS. For equations, we want to go in reverse. So first we want to do the addition and subtraction, then the multiplication and division, and then anything else. So let's see example 1. We have 5x minus 2 equals 13. I want to do the addition and subtraction first. So instead of subtracting 2, the inverse operation is to add 2. So I get 5x equals 15. Now we're back to just a one-step equation, which we just worked on. We're doing the inverse, and our answer is x equals 3. The beauty of equations is you can always check your work. We can always take our answer and plug it back into the original to see if it works out. So let's do that on the right here. I'm going to take that original, 5x minus 2 equals 13, but instead of x, I'm going to plug a 3 in. I'm doing order of operations now. 15 minus 2 equals 13. 13 equals 13. That is a true statement. Because it is true, I know that my answer of x equals 3 worked out. That's correct. Example number 2. 1/2 times x plus 6 equals 2. Again, start with addition and subtraction. So since I'm adding 6, I want to subtract 6. Watch your sign. Now I'm back to a one-step problem. 1/2 times x. I want to divide both sides by 1/2. And I get x equals negative 8. You can check your work over here, and it will equal a true statement. A tricky problem here. Trickier than you think. So we have 7 minus x equals negative 15. Start with addition and subtraction first. Notice that in front of the x, there is a number. That number is negative 1. So we're saying 7 minus 1 times x. So again, start with the addition and subtraction first. This right here is multiplication. Negative 1 times x. So we're not starting with that. We're going to start with the 7. Currently, it is a positive 7. We are adding 7 up here. So to undo that, we want to subtract 7 from both sides. That's one mistake people make. They'll just add 7. The next mistake is when they're bringing down the x, they forget to bring down the negative sign. When I subtracted 7, that just got rid of this. I still have negative 1x there. Notice, the x is not alone. We are not finished with the problem. We want x to be alone. This negative has to go away. So again, this says negative 1 times x. To get rid of multiplication, we divide. And we get x equals 22. That is our answer. You have to be really careful to bring down the sign if it's in front of the x. Up until now, we've just always seen a plus x. So a plus 1x. And then we haven't done anything with that because if you divide by a 1, it's still that answer. So if there's a negative in front, you really have to take your time and bring it down. Okay, I want you to try these 5 problems now. Pause the video and try them, and then check your answer with mine. I'll write the answers in here. So please pause the video.